Find the equation of the perpendicular bisector. What is a perpendicular bisector? A bisector divides a line segment into two equal parts. It will cross the segment at its midpoint. We have already found the midpoint because it is required to bisect A and B. Then it will pass through the point which is halfway between A and B. And we have found the midpoint of the segment AB already to be 1, 3. So the first part is done. We have the point through which the line passes already. The line should also be perpendicular to AB. We have our line segment there representing the line which should be perpendicular to AB. The most efficient non-graphical way to find the equation of a straight line is to use its gradient and one point through which it passes. We already have the point through which it passes, and we need its gradient. The relationship between two lines is reflected in their gradients. We have two lines that are related to each other. As a matter of fact, they are perpendicular to each other. That relationship is reflected in their gradients. The two lines are perpendicular to each other. If two lines are perpendicular to each other, the product of their gradients is equal to -1. When we multiply the gradient of one by the gradient of the other, the result is -1. And if we have the gradient of one, it is quite easy to find the gradient of the other, because the gradient of the other will be the negative reciprocal of the first one. The gradient of one is the negative reciprocal of the other. And of course, the converse is true. If we have the first one, we do the reciprocal and change its sign. If we have the second one, we do the reciprocal of the gradient and change its sign. And we will find the gradient of the other. Therefore, we will say that the converse is true. Now, in finding the gradient of the perpendicular bisector, which we need to be able to find its equation, we will take the gradient of the line that we have right here, the gradient that we found, to be -1/2. How do we find the gradient of this one, which is perpendicular to it? We will find the negative reciprocal of this. We will do the reciprocal and change its sign. Now, changing the sign will give us a positive gradient, and the reciprocal of 1/2 is 2. Therefore, the gradient of the perpendicular bisector is 2. We have the gradient of the perpendicular, which is 2, and we know one point through which the line passes, which is 1, 3. If we have the gradient and a point through which it passes, we will go straight ahead and find its equation, and we will do that on the subsequent slide. We may make use of the gradient and its associated point along with the student's favorite formula in finding the equation of the perpendicular bisector. We will make use of the gradient, we will make use of the associated point, and we will make use of the formula. So we have here the gradient, which is 2. We have the coordinates of the point, which is 1, 3, and which of course we are enlarging here for the visual effect, and the student's favorite formula, which is y is equal to mx plus c. Now, y, the value of y is 3, as we see. The value of the gradient is 2, and the value of x is 1. Y is equal to mx plus c. It is very clear here. 3 is equal to 2 times 1 plus c, which we will have here, and we are going to convert that using the values. C is the only thing that we do not know. We have it here. Y, which is 3, is equal to m, which is 2, 3, 2. X is 1, and we do not know the value of c. We will therefore go straight ahead and make an attempt to find the value of c. First, we will simplify that expression. Not by very much. We have 2 ones, 2. That's all. And it is clear that if 3 is equal to 2 plus something, what is it that we add to 2 and the result is 3? Then we don't need to do much transposition to see that if we add 1 to 2, the result is 3. Therefore, c is equal to 1. The equation of the line will be, of course, y is equal to mx plus c. Y, of course, is the general form now. Y is equal to m is 2, x plus c is 1. So y is equal to m is 2, x plus 1. Y is equal to 2x plus 1. That is the equation. And we have found the equation of the perpendicular bisector of the line segment AB. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.